Look up at the night sky. Every tiny dot you see is a nuclear explosion burning for millions or billions of years. But here's the strange part. Not all stars are the same. Some live forever, some die violently, and some shouldn't even exist.
Stars are the engines of the universe. They forge the elements in your body, shape galaxies, and decide the fate of everything around them. Without stars, there would be no light, no planets, no life. But stars aren't just big glowing balls. They come in different types, different sizes, different personalities. Each one tells a different story about how the universe works. So today, we're going on a journey across the cosmos to meet every kind of star that exists. Every star begins the same way, in darkness, inside vast clouds of gas and dust called nebulae. These clouds drift silently until gravity pulls them together. Slowly, they collapse. Heat builds, pressure rises, and then ignition. A star is born. At its core, hydrogen atoms are crushed together to form helium. This process, called nuclear fusion, releases an enormous amount of energy, and that energy pushes outward, balancing gravity pulling inward. This delicate balance is what keeps a star alive. Let's start with the most common stars in the universe, red dwarfs. They are small, cool, and incredibly long-lived. Some can burn for trillions of years, far longer than the current age of the universe. They're like slow-burning candles, quietly glowing in the dark. Now meet stars like our sun, yellow dwarfs, medium-sized, stable, perfectly balanced. Not too hot, not too cold, just right for life to exist on nearby planets. We owe everything to a star like this. Then things get more intense. Blue giants. Massive, blazing hot, burning bright and fast. They live only a few million years. Compared to red dwarfs, they are cosmic fireworks. Brilliant, but short-lived. And then there are the extremes, red giants. When stars like our sun run out of fuel, they expand, swallowing nearby planets. Their outer layers stretch outward, while their core shrinks. One day, our sun will become one of these. But stars don't live forever, and how they die depends on their size. Small stars, like red dwarfs, fade slowly. They never explode. They simply cool down, becoming dim, dead remnants. Stars like our sun die more dramatically. They shed their outer layers into space, creating beautiful glowing shells called planetary nebulae. At the center, a tiny, dense core remains, a white dwarf. It's incredibly small, about the size of Earth, but contains half the sun's mass. Imagine squeezing a mountain into a teaspoon. But the real chaos begins with massive stars.
When massive stars die, they don't go quietly. They explode, a supernova. For a brief moment, they can outshine entire galaxies. And what's left behind is something truly bizarre. Sometimes the core collapses into a neutron star, a city-sized object with more mass than the sun, so dense that atoms are crushed and only neutrons remain. A teaspoon of it would weigh billions of tons. Even stranger, some neutron stars spin rapidly and emit beams of radiation, like cosmic lighthouses. We call them pulsars. And then, the ultimate extreme. If a star is massive enough, it collapses into a black hole, a point where gravity becomes infinite. Not even light can escape. A star that becomes invisible. Every atom in your body, carbon, oxygen, iron, was created inside a star and scattered across space by stellar death. You are not just in the universe, you are made of it. Stars are not distant objects, they are your origin story, and their life cycles shape everything we see.
Some stars burn slowly, lasting longer than anything we can imagine. Others explode in violent endings, rewriting the universe around them. But all of them, from the smallest red dwarf to the largest supergiant, are part of the same cosmic cycle: birth, life, death, rebirth. So next time you look at the night sky, remember, you're not just seeing stars, you're witnessing the past, present, and future of everything that exists, including you.